What's up, everyone? As of version 3.28, there's a new way to include an HTML converter in your lexical editor. In a previous video, I went over how to do this in a way that's no longer supported. So I'm revisiting the topic to give you an updated view on how to render HTML on your front end using your lexical editor. If you want the code I use in this video, there's a link to the repo in the description. Now, let's dive in. Previously, you would import lexical HTML and the HTML converter feature from Payload's Lexical package. You would then add the HTML converter feature to your editor configuration, and then include the lexical HTML field with some configuration options in it. This would take your lexical editor's input and automatically convert it to HTML for you. All along the way in setting this up, there were warnings that it would eventually be deprecated in Payload version 4, but the team has expedited that process. Why? The old converter imported everything from Lexical, so it was a heavy implementation for something that shouldn't have been nearly as heavy. Beyond that, it could only be used on the server, so client-side implementation was out of the question. Lastly, it wasn't easy to implement. The process wasn't straightforward, and it was hard to pass in the correct arguments for it to work properly. The new way is lightweight and much easier to use. It also fixes the issue of only having to implement on the server by adding client-side options. There are 3 ways you can implement this new way of doing things. The first is to generate HTML on demand, which is recommended. You'll want to set this up as your own component, so we'll create a new folder in our components directory, and we'll call this render HTML. And inside this, we'll have a new file called index.tsx. We're going to use the useClient directive so we can have a client component, and we're going to import our type of serialized editor state from our rich text lexical package, and then a new function called convert lexical to HTML, which comes from rich text lexical /HTML. We'll then import React from React. If you're using another framework or JavaScript library to render these blocks, you won't need to include this. I'll now export a constant called render HTML and set it equal to an arrow function. And the props for this arrow function is going to include data, and that data is going to have the type of serialized editor state. We'll have a constant called HTML to store our results from our convert lexical to HTML function. We'll pass in data. So other than data, there is a few other options here, some that we will include, some that we won't. Class name is first. It's a string of class names for the converted HTML. We'll then have disable indent. So if you don't want indents to be rendered, you can disable them here. You can disable the container that comes with the returned data from this function, and you can also disable your text align here. We'll also have our converters option, but we'll need to come back to that later. Below this, we can return a div that dangerously sets our inner HTML to our HTML results from our convert lexical to HTML. We can then use this in place of our rich text component. To show this, we'll go to our source, app, front end, posts, slug, and then to our page.tsx file in there. Instead of our rich text component here, we're going to duplicate that and comment out our render blocks, our old rich text, and our plain text here. That way we can see exactly what we're doing. So we'll replace our rich text with render HTML, and we'll pass in still our post content here. We can run pnpm dev, then we'll go to our posts, blog 2, and then we can see some HTML returned here. The class name that we could have passed in is added to the container div that returns all of this lexical data. We won't see much difference from our current implementation, except that our blocks don't work anymore. That's because, similar to our rich text component, we need to define the blocks we want to use. So let's add a block to our lexical content. We'll just use our content with media block in our blog 2, and we can get rid of our testing here and add our content with media block. And in here, we'll just write, this is a content with media block. We'll set text position to left, and we're going to choose from existing and just use my headshot here. And we can publish these changes. But now if I go back to our blog 2 and refresh, we can see that nothing changes. So now let's get our blocks showing in this new HTML renderer. Back in our render HTML component, we need to import a few things. So first we'll import our types of content with media from payload types as well as media. We'll also need to import a couple of types from our rich text lexical. So we'll import type, default node types, as well as serialized block node, and this is going to be from our Payload CMS rich text lexical. And then in addition to our convert lexical to HTML, we need a type of HTML converters function. Now we need to define our type of node types and set that equal to default node types. And then we need our serialized block node with content with media, but not our media here. I'm only going to use one block, but you can include multiple blocks by using the union operator here. And if you have inline blocks, you can use the serialized inline block node in the same way. We now need to define our block converters with a constant called HTML converters. So constant HTML converters, and the type of this will be HTML converters function with our node types. And we'll set that equal to our props here, which will take the argument of default converters. And we can pass in all our default converters using the spread operator here, and then add our blocks option below it. Again, I'm only using standard blocks here, but you can use inline blocks as well by just including the inline blocks option. I won't do that. We'll set our content with media and then open up an arrow function. So first, we're going to go over the arguments that we can include, which the first one is node. This is the actual block data. You can use your fields from here. You also get a provided CSS string, and this is an argument that you can use to pass in a CSS string to style your block. You also can do the same thing with a provided style tag. And then also converters are available to you, as well as nodes to HTML. The converters option here can accept HTML converters like we're defining right now. The nodes to HTML option takes a few arguments. After nodes to HTML, you have your child index, which is the index number of the block in your lexical editor. For example, this content with media block we added is child index 4. And then our parent, which is a reference to the parent node where this block is located. So now with all of those options defined, we can first get our constant rich text and set it equal to node fields content to check if that exists. And if it does, we'll use our convert lexical to HTML and pass in our data of node fields content. I can remove our provided CSS string and style tag, as well as our converters, nodes to HTML, child index, and parent, because I'm only using my node here. Below our rich text, we'll include our image, which we're just going to have as node fields image as media. And then we can return an HTML block of what we want this component to look like. So I will keep this really simple by using Tailwind classes. So we'll set this to be display flex, flex wrap, padding of 4, margin left and right of 4. And then within this div, we'll have another div, which will have a class of first checking node fields dot text position equals right. And if it does, we can pass in order last. If it does not, it can be order first, and it can have a width of 1/2. Then we can pass in our rich text field right here. As a second part to this div, we can include an image tag, which will have a class of width of 1/2. It'll be rounded, medium, and an alt of our image.alt, and our source will be our process.env, so our environment variable for our next public S3 bucket, and our image.filename. Now that this is done, we need to add it to our converters by adding our converters here with HTML converters. I see up here that our image has an error. It's because I did not set class equal to width of 1/2 rounded medium. So now it recognizes the alt attribute there. So now if I save this, and refresh, we see that our content with media block shows up as intended. The second way you can generate HTML from lexical content is to output it from the collection. This is not recommended as it will add overhead and may not work well with your live preview. It also does not work with relationships out of the box. Doing it this way will recognize the ID of your relationship, but you will not have an easy way to fetch that relationship to be used on the front end. It works just fine for text though. However, you may find cases where you need to do this, so here's how. In our posts config.ts, so we can go to our collections, our posts, then our config, and within this, we'll find our content field, which will be our rich text lexical field here. And below it, we're going to add the lexical HTML field, and this will take some options. The first one is the HTML field name, which is what the name of this field is going to be. So I'm going to do content HTML. Then we need the lexical field name, which we'll set to be content. So this is the name of the field we're converting. We're converting our content field up here into HTML. We'll want to set hidden to false, but you can set this to true if you don't want a code field to show up in your admin UI. You can also set store in DB to true if you want it to be stored in your database, but it is false by default. We can then include our converters, which will have our default converters, and then we will pass in all of our default converters, and this is done. This field will convert your rich text field into HTML using an after read hook. If you leave hidden as false, as I mentioned, you'll be able to see the rendered code in a code field. So if we go over to our post, we can see a content HTML field and the rendered code here. Of course, since I didn't include a block converter, we're not able to see what our block would look like. It just comes back as unknown node. However, if I do just paste in what I had for my other block and save it, we can see in the after read hook, after it runs, that our alt description and our file name are undefined, but we can see our text just fine. Now to get this to render, we can check post content HTML exists, and if it does, we can create a div with dangerously set enter HTML with the HTML set to post content HTML. And then when I save this, we'll see the text as well as our rich text, but no image because the block could not be defined since all we got back was our ID. The third and final way to render HTML on your front end is to use dynamic population. The convert lexical to HTML function expects fully populated data, including links and relationships. If you need to fetch those dynamically to populate the nodes, you can use the async version of the function, which is called convert lexical to HTML async. And this comes from the rich text lexical /HTML async package. Doing it this way requires a populate function. So let's go over all of that by creating a new directory that we're going to call generate HTML. In our generate HTML, we'll have a file called index.tsx, and we're going to start with the client version of this. So we'll use the use client directive, and we're going to import our type serialized editor state, just like before. Then we're going to get a new function called getRest populate function, and this is going to come from rich text lexical client. Then we'll import our convert lexical to HTML async, which is going to come from our rich text lexical HTML async. Then we need to import React and then use effect and use state from React. Then we'll import our type content with media as well as our media type. Then we need our type serialized block node, then our get server side URL. Now we can generate our HTML using a constant called generate HTML, and this will be set equal to data, which will have the type of data serialized editor state. We'll then create a use state hook, which will get our HTML and set our HTML. the default value will be null, and this will take either a null value or a string. We'll then need a useEffect hook, and in this hook, we are going to have our data be a dependency, and then we can build out the function within the useEffect hook. We're going to need an async function called convert to HTML, which inside that is going to have a constant called HTML, which will await our convert lexical to HTML async. So this imported something that I don't want, so I'll remove that import. And now I can get our data. And then in addition to our data, we need a populate function, which will be get rest populate function. And then in this, we need our API URL, which we will get from our get server-side URL, and then our API route here. Now, like before, we need to use our converters, which will have our default converters, and we can use the spread operator to get all of our default converters. And finally, we need our blocks, which will have our content with media. We'll have an async node with our node's type being serialized block node, content with media. Then in our rich text, we are going to have our node field's content be checked to make sure it exists. If it does, we can await our convert lexical to HTML async function and pass in our data from node field's content, and our image, which will be node field's image as media. We can then return that same HTML that I created before. Below all this, we can set our HTML to be HTML, and then we can void our convert to HTML function. And lastly, we're going to return if HTML exists. We can return our div dangerously set inner HTML to be our HTML. Now I can go to our page.tsx file, and we're going to comment out our previous examples. We can then check if our post.content exists. If it does, we can import our generate HTML and then pass in our post.content. Now I can save this, and we shouldn't see anything change in our content except for the removal of our previous examples. Client-side rendering can be a good choice for this, but if you have large nodes or lots of data, you may be better served by using server-side rendering. This can help speed up your HTML generation if client-side is a bit slow. We'll do this in the same file and just comment out my first component completely. So I can go here, select all, and comment that out. And below this, we're going to import our type of serialized editor state. We can then also get our types of content with media and our media from payload types. We'll import the get payload populate function from rich text lexical, as well as the type of serialized block node. We'll also need to import our convert lexical to HTML async from our HTML async package. Then we need our get payload from payload, React from React, and then our config from payload config. Now we can export a constant called the same thing, generate HTML, and we'll set it equal to async data with the type of serialized editor state assigned to our data. We'll then need to get our constant payload and initialize payload by awaiting get payload and passing in our config. Then we need our constant HTML and set that equal to await convert lexical to HTML async, which takes our data, and again, we need a populate function, and we can await our get payload populate function here with a current depth of 0, a depth of 1, and then our payload object here. Then, of course, we need our converters, which first we need to use an arrow function, and then get our default converters and pass those in with a spread operator. Then we need our blocks option, which will get our content with media option, and that will be assigned the async function, and we'll just pass in an arrow function here. In our arguments, we'll pass in our node And our node will have the type of serialized block node, content with media. Then within the function, we're going to set a constant called rich text equal to node fields content, check that that exists, and await convert lexical to HTML async, and pass in our node fields content as data. Then we need a constant image with that set equal to node fields image as media. And then we can return the same HTML we've been using. We'll then return HTML, check that that exists, and then return our div dangerously set inner HTML set to our HTML response up here. Now I can save this, and since we already have our generate HTML component set in our page.tsx, we can just check to make sure that our block is still there, but it should look exactly the same. And that's 3 ways to render lexical data as HTML on the front end. In most cases, my first example should be sufficient for whatever you need to do, but you do have a couple of options to choose from depending on your use case. If you found this video helpful, please like it and share it with others who might also find it useful. Check to make sure you're subscribed to my channel and receiving notifications so you never miss when I release more content around Payload CMS, Next.js, and more. If you have suggestions or questions, please leave those in the comments. I'd love to hear from you. Until then, I'll see you on the next one.